The capacity for XR technologies to enhance nearly every component of our existence is paralleled only by developments like the internet or industrial revolution. Its ability to alter our lives in such a pervasive and comprehensive sense cannot be overstated, though the sheer volume of technological advancements that are required to reach its ultimate potential are prolific and far-reaching. In the first portion of this video, I will primarily be exploring the use cases of fully mature AR glasses, but the scope of this discussion will expand far beyond head-worn devices and into the realms of the distant future of this technology. After I finish this initial segment focused on applications for AR glasses, I will expound the obstacles that inhibit the viability of these use cases with current hardware, and then lay out the respective advancements that will have to be made for them to be realized. I will begin with one of their most notable applications, holographic video calls, or what is formally referred to as volumetric telepresence within the XR space. As opposed to simply viewing someone's face on a screen, one can have the person they wish to communicate with appear in front of them, in a way that allows both individuals to feel truly present with one another. This will not only greatly extend the level of immersion within the video call itself, but permit a level of interaction between its participants that simply isn't possible via 2D media. For example, you could play chess or a game of cards with someone who could be thousands of miles away, or simply hang out and browse YouTube videos or watch a movie with them. This serves as only one implementation of an entire new category of video content called volumetric capture. The vast quantity of ways this new medium could be utilized are as diverse as existing applications of media consumption. Imagine being able to watch a podcast where the host and guest appear in your room as holograms, or the ability to watch any given form of video incorporating this technology in the same fashion. The president could give a speech in your living room. A concert of your favorite artist could be volumetrically captured so you can watch them appear in your home to give their performance. Sports games could also be viewable in this manner. Obviously, due to the disparity in size between a football field or basketball court and a room in your house, you'd be unable to watch the entire game take place at full scale via volumetric video. But pivotal moments, like a player getting tackled, the lead up to a touchdown, or someone scoring a slam dunk could be viewable by means of volumetric video. For instance, if a player was moving across the football field to the goal line with multiple others pursuing him, while you'd still see them all as life-size holograms running in your room, their movement would be fixed or greatly limited. In effect, this would bypass any restrictions that viewing such content in one's home would present. Perhaps more intriguing, once the giant capture rigs that are entailed for recording this content are miniaturized, this form of video could be used to capture moments in one's daily life, similar to how we take 2D videos and photos today. Imagine being able to record holographic videos and photographs of any moment in time, like your child taking their first steps, or the moment you got married. This would consequently enable us to have holographic recordings of people after they're deceased. You could watch a hologram of a dead parent or loved one appear in your room opening up their birthday presents, or of you playing with your late childhood dog when you were just a kid. This will empower us to revisit cherished memories in a richer way than contemporary means of doing so allow. Another way to employ this technology would be to view apparel on yourself prior to purchasing it. For instance, when shopping online, you could see the pair of shoes you're looking at superimposed over your feet, or better yet, have a hologram of yourself appear in front of you, with the shirt or pants you might buy photorealistically overlaid on top of it. In the second part of this video, I will outline a different set of use cases, many of which are arguably even more profound than what my original catalog consists of. To start with, one of these applications would be to never lose or misplace anything again. Suppose you set your keys or wallet down somewhere and don't remember where you left them, or you forget where you parked your car or stored something in your home. Due to AR glasses having to map out the real world through the use of sensors such as GPS, accelerometers, and cameras as a requirement for their tracking to function, this would enable the glasses to track your movements and surroundings in real time. Simultaneously, the cameras on the glasses would have a consistent view of your hands, along with the ability to recognize and identify objects through computer vision technology. This means that the glasses could detect when you put an object down and remember its location. You could simply ask, "Where are my AirPods?" or "Where'd I leave my keys?" and the glasses would use their sensors and computer vision to locate the last known position of the object. An arrow could then appear in your field of vision, guiding you to the location where the cameras last saw you setting down the lost item. Another way AR glasses could assist users is by detecting whether someone's lying to them. The glasses could analyze someone's facial expressions and detect changes in the way their voice inflects via its camera and speakers, and then through AI, determine whether a person is likely to be telling the truth. It could then inform you mid-conversation through text displayed in your field of vision that it's likely someone's lying to you. The potential uses for AR are virtually endless in social scenarios. Imagine you're trying to explain something to someone and effectively convey your point, but the person's still unable to grasp your reasoning. The glasses could detect this and then display analogies that you could use to express yourself more cogently, or show you arguments to employ in favor of your point of view. It could even be misused and increase your ability to be manipulative. For example, if you were trying to get someone to do something for you, in the midst of your conversation, the glasses could suggest convincing arguments for you to exploit to try to make them comply. It could even tailor them for each individual person, based on things that have worked in the past and they're emotionally receptive to. Another use case could be a kind of predictive text for your conversations. When talking with someone, it would analyze your speech pattern in the conversation's context, so if you lose your train of thought or can't find the right word to use, it could predict what you were trying to say and generate the potential words in front of you. By default, this would also increase your functional vocabulary and allow you to organize your syntaxes and pick your choice of words in a much more skillful way. The glasses could also identify any given thing you wish to receive information about. For instance, if a car piques your interest as it passes by, you could simply glance at it and make a subtle eye gesture, and within moments, a virtual web page could appear before your eyes, displaying relevant information such as the car's model, year of manufacture, and typical retail price. Or maybe you see someone walking by that's wearing a shirt or pair of pants or shoes you like. Through the same means of a simple glance, you'd prompt the glasses to recognize it, subsequently inform you of what brand it is, and display a site where it's available to purchase. Obviously, the use models I've covered so far merely scratch the surface. Many others have been widely discussed, like the ability to display virtual screens that can be rescaled to sizes that far exceed what smartphones can offer, or to provide visual cues that allow you to assemble anything with ease, regardless of its complexity. Additionally, I anticipate that once the tech for full AR glasses is created, we'll continue to develop novel and unforeseen ways of how this technology can be applied, similar to what happened with smartphones and the internet. Which brings me to my next point. What advancements need to occur to create a device that can actualize all of this? As I mentioned early on, a myriad of technological developments are necessary for AR glasses to achieve their full promise. After I finish discussing them in this next bit, I'll move on to how different incarnations of this technology, like contact lenses and neural interfaces, can complement its utility and engender entirely new use cases. One of the main obstacles that prevents much of this from being practical with current AR headsets is their field of view. One of the first positionally tracked see-through mixed reality devices to hit the market was the HoloLens 1, which debuted in 2016. It boasted just a 34-degree FOV, a far cry from the vast portion of your field of vision a regular pair of glasses encompasses. Subsequent iterations of this device category have achieved larger FOVs, but have yet to reach parity with even current VR headsets, which on average sport a 110-degree field of view. As of 2023, the see-through AR headset with the largest FOV on the market is the Magic Leap 2 at 70 degrees. Why is this important? Many of the applications I listed in the first part of this video aren't suited for devices with such restrictive field of views. For example, in this recording I demonstrate the limitations of the HoloLens 1. In order to see the hologram of this person in full, you have to stand back about 25 feet. If you move any closer, or even turn your head a bit to the side, the illusion is immediately broken as parts of her body are cut off. Although this is an extreme example, due to the original HoloLens having a much lower FOV than more recent devices, all current see-through AR still suffers from this restriction to some degree. This isn't ideal for obvious reasons. Imagine trying to have a holographic video call with someone where you have to stand back a couple dozen feet to fully visualize them. Even though there have been major improvements on this front in newer HMDs, they still fall short of the 90 to 110 degree field of view that's required to make viewing volumetric content truly practical. Another issue is that in order to capture someone volumetrically to enable this type of telepresence, it requires a vast array of cameras surrounding you at all angles. But eventually this will change, due to something called codec avatars. The idea behind them is that instead of using hundreds of cameras to capture someone for co-presence, You could fake it in a way that is visually indistinguishable from doing so. With just a few pictures of yourself, an AI algorithm could create a photorealistic rendition of you. Then, through sensors on the glasses that detect facial expressions and body movements, it can overlay them on your holographic replica with one-to-one accuracy. But that's just for telepresence. Democratizing volumetric capture so that anyone can make their own holographic video content will still require camera rigs. And in order to make them accessible to people, the size and amount of cameras required will have to be scaled down significantly. Instead of an entire room full of sensors pointing at you from all directions, you would need to have just a couple that are stationary, maybe one on top of your TV stand and the other on your coffee table, so that they can focus on anything in the room from opposite angles. That way, you could just tell the cameras to start recording on a whim, and any people visible to them would be volumetrically captured. After the cameras have finished recording, the holographic video could be wirelessly synced and available to view on your glasses. In terms of capturing still volumetric photos, they could potentially just be taken via the glasses themselves. This is already possible through smartphone apps like Value that allow you to create holographic photographs by solely using your phone's camera. Currently, this is a novelty when viewed with phone AR, but once it's carried over to glasses that have an adequate field of view to make use of this feature, it'll become a new and powerful method of photography. In terms of the rest of the uses I laid out, the progress that their practicality necessitates in large part just consists of AI advancements, and with all the major developments occurring recently within the field, some of the things I mentioned, like conversation assistants, could potentially already be utilized with existing LLMs like ChatGPT. Which leads to my next point. Even if we created a device tomorrow capable of everything in this video, until we shrink down the size of AR headsets to a pair of glasses, it still wouldn't reach the necessary threshold of being a mainstream consumer product. Current AR devices are large, heavy, and not meant to be worn for prolonged periods of time. This is due to many different factors. They range from the size of the waveguides needed for an FOV that allows compelling use cases, to the sensors that are required for simultaneous localization and mapping, which allows you to positionally track virtual objects. These two examples I listed are among many other things that contribute to their current bulky design. But due to the amount of time it'd take to extensively list and review them, I will leave it at that for now and move on to my next topic.